Hello everybody. This video we will study the fourth program of AtCoder beginner contest 351 grid and magnet. Okay, so this is the problem statement. In the grid, here are two kinds of mark. One is dot. It means the cell is empty. The other is pound mark. It means the cell has a magnet. So it's a trap. We can't go to the cell with the pound mark. Here is also a special condition. If the dot has a neighbor of pound, when we go to the cell, we can't move anymore. Like this. Okay, if we go here, we cannot move anymore because the above cell is a magnet. So in fact, here are three kinds of mark. One is magnet, one is real empty, and the other is stop cell. We can use some character like a question or other characters. So this is the first, second, third mark. Okay. So let's see the first sample. Here, in fact, this is a question, and a question. Okay. And if we start from the first row and the first column, the answer will be 1. And if we start from the second row and the first column, the answer will be 1, 2, 3, 4. And if we start from this or this one, the answer will be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, okay? This 9 and 1, 2, 3, 1, 2, 3, 4, 1, 2. So here are 9 cells in total. So the greatest answer is 9. Okay, now let's study the second sample. Because each of the empty cell has a neighbor of pound mark, so the answer will be 1. Any of the empty cell. In fact, all these empty cells are not a real empty cell. They are stop cell. Here 1, 2, 1, 1, 1, 1. So when we go any of the question cell, we can't move anymore. So we will take our third sample. For example, 2 rows and 4 columns. And this is so we can change part of the dot to question. Okay, if we start from the first row and the first column, the answer will be 1 here. And if we start from the first row and the third column, the answer will be 1, 2. Okay, 1, 1, and 1, 3, if we from the first row and the fourth column, the answer will be 1, 2, 3, 4, 5. And 2, 1, the answer is 3. And 2, 2, the answer is 1. And 2, third, the answer will be 5. And 2, 4, the answer will be 5 again. So the greatest answer is 5. We output 5, okay? And here we notice that here are 3, 5. That means the calculation position has many repeated steps, so we can ignore some of the repeated steps to improve the algorithm efficiency. Okay, so let's take some flag to cover the traversed cells. For example, if we go from the first row and the first column, we put 1. Okay, because we can't move anymore, so the first, the number 1 only occupied 1 cell, and here is the second area, and here is the third area. So notice that this flag has been changed because it's okay. The stop cell can belong to different region or area. So this cell both belongs to the second area and the third area. Okay, and this one, this is the fourth. 3, 1, 2, the fourth area, 4, 4, 4. We can change the flag of the question cell. Okay, and notice this. 3 is the same as previous flag, so we don't need to calculate these 2 cells again. So we can, because we don't need to calculate them, so we make our calculation more efficient. Okay. Now let's code according to this idea. Include bits using namespace std int main. The max age is 1000. Input h and w for into row from 1 to h and column from 1 to w. Input the mark of the cells. Okay. Now we change some empty cell to question cell because of the pound neighbor. If the current cell is dot, but it has a pound neighbor. My order is up, down, left, right. This is the first, the upper cell, and this is the down cell, and this is the left cell, and this is the right cell. Okay, here stop. Stop means we can go here, but we can't go anymore. So we can define a stop macro. Const char stop it can be any visible character besides of dot and pound. Okay, now we compile. Okay, we need to define H and W. No. Input ARC. Okay. The first, second. Oh. Okay. Again. Okay. Now we can traverse. Here are two kinds of situation we can traverse. First is the cell is a stop cell, and the second is the cell is a real empty cell, and it has not been wasted. Like this one. This is dot. Here is dot and the question dot dot. This one we first traverse the dot. It has been not wasted, so we can traverse. But this two has the same ID of this one, so we don't need to traverse these two cells again. Okay, so here we have 3 cells. We only need to traverse the first cell. Okay. Now here if ARC is a stop cell or ARC is an empty cell, and so here we need we can use ID as the waste number. So int with max h and max h. So here ID RC and ans max ans and count. count what? Count ID. Finally, we output the ans. Okay, here, what's the ID and the count of ID? For example, here is the first ID, and it can't go anywhere. So only one cell with the ID of 1. Okay, now here is the second ID. Okay, and here is the third ID. So count 1 is 1, and count 2. Count 2 is here, is 1. Now count 3, 1, 2, 3, 4, 5. Count 3 is 5. And here is 4. 4, 4, 4. Count 4 is what? Is 3. And no count 5, because we don't need to traverse the last 2 cells. Okay, so the answer will be 5. So now we need a 2. Here is an ID and ans and the count of okay. Define our depth first search function. Okay, compile, no error. Okay, and here with RC count ID increase. Okay, now here we have 4 direction. I increase. So const in the direction. Here I often use the up, down, left, right order. So this is up towards, this is downwards, and this is leftwards, and this is rightwards. Int next row. Update, and this is the next column. DFS. Okay, now we need to search the condition. The first condition is row don't outbound. And column don't outbound. And the next row can't be magnet, can't be pound. A next R, and next column. It's not a magnet. And the next with can't be the same ID. But for example, for the last sample here, okay, if we traverse and it go left, it's okay. And the left can't be go right again, because this cell's ID, flea and flea, they are the same ID, so can't go right again. Okay. Now it seems the code are finished. Okay. And let's test first. 6. Okay, something wrong happens. Here, okay, here. Oh, if ARC, if it's a stop cell, stop, we can't go anymore. Now we test again. 1 is okay, and for the first sample, okay, for the third sample, dot count dot 5 is okay. Now let's test. Okay, the solution has been accepted. Okay. So here we change part of the empty cell to stop cell. Then we use ID to mark each area traversed. So this is a typical DFS problem, and it's a good problem. Now our task is finished, and see you next time.